Let's discuss calculating wire sizes for your transformer setup, adhering to the National Electrical Code, or NEC, guidelines. We'll focus on both the secondary and primary cable sizing for the two transformer loads you specified, keeping in mind you intend to use XLP, 133% concentric neutral primary underground cable and underground secondary cable. For the first load of 155.6 kV amps, we have a 225 kV amp transformer, 3-phase 208 delta/120 volt secondary with a 12,460 volt primary. The secondary current calculation yields 155.6 kV amps divided by 208 volts times the square root of 3, which equals approximately 431.9 amps. Now, to determine the appropriate secondary conductor size, let's refer to the NEC. Using NEC table 310.16, assuming a 60 degrees Celsius termination temperature, and utilizing THHN conductors, we find that a 600 kc milled cable is suitable for carrying 431.9 amps. For the second load of 57 kV amps, we have a 75 kV amp transformer, 3-phase 208 delta/120 volt secondary with a 12,460 volt primary. The secondary current is calculated as 57 kV amps divided by 208 volts times the square root of 3, equaling approximately 158.2 amps. Again, consulting NEC table 310.16 for 60 degrees Celsius THHN, a 1/0 AWG conductor is appropriate for this current level. Now, let's address the primary cable sizing. You mentioned wanting to use 133% concentric neutral XLP cable. The NEC doesn't specifically list this exact cable type and ampacity. However, we can use a calculation-based approach to estimate the appropriate size. The primary current for the first transformer, the 225 kV amp 1, is calculated to be approximately 7.2 amps. The primary current for the second transformer, the 75 kV amp 1, is approximately 2.6 amps. Because the NEC does not specify for the type of cable or its ampacity to estimate an appropriate primary cable size for this concentric neutral XLP cable, we're going to use a formula. Cable size, expressed in kc mil, equals transformer kVA divided by open parentheses primary voltage times the square root of 3 times 0.8 close parentheses times 1.33. The 0.8 represents an 80% loading factor. The 1.33 is to get that 133% neutral requirement. For the first transformer load, this becomes 155.6 divided by open parenthesis 12,460 times the square root of 3 times 0.8 close parenthesis, all times 1.33. The calculation yields approximately 152 kc mil. For the second transformer load, 57 divided by open parenthesis 12,460 times the square root of 3 times 0.8 close parenthesis, all times 1.33, yields approximately 69 kc mil. In summary, based on these calculations and NEC guidelines, you would need 600 kc mil THHN cable for the secondary of the first transformer, and 1/0 AWG THHN cable for the secondary of the second transformer. For the primary side, you would need approximately 152 kc mil 133% concentric neutral XLP cable for the first transformer and approximately 69 kc mil 133% concentric neutral XLP cable for the second transformer. Keep in mind this is an estimation of wire sizing. Always consult a qualified electrical engineer or local electrical inspector to ensure compliance with all applicable codes and regulations, including local requirements and specific installation conditions. Also, verify the specific ampacity ratings of the XLP cable you intend to use based on the manufacturer's specifications.